All right, so today we're going to do deductive reasoning. And like I was saying a few minutes ago, the first year that I was teaching this, I made some really dumb mistakes that in hindsight I should have understood it better. So, all right, so the last few days we've been doing inductive reasoning. What's inductive reasoning based on? Patterns. And remember what I said, inductive is like intuition, like what you feel is happening. Yeah? You always, anytime we start proving something new, that's how you start. You're like, wait, I think there's a pattern here. And then you find the pattern, and then you spend the rest of the time doing what? Proving why the pattern is there. And that is deductive reasoning, yeah? It's the backbone of geometry. If you go back in time, and the Greeks were incredibly good at this, yeah? Have you ever heard of Euclid? There's a book called Euclid's Elements, and it's a book of proving all the geometry stuff. He starts off with some very simple things, and he ends up throughout the books, volumes of the book, proving like a crazy amount of math with just a few things that he starts out with. So it's pretty cool. So deductive reasoning is different. It's based on facts and rules, definitions, and properties. One thing I wish I had known when I first doing this is if it starts with an if-then, that's a rule, yes? Remember I said if you hear an if-then, the if-then is considered a rule. So when you read something and you hear an if-then, that is a rule. You're guaranteed that it's deductive reasoning. Yeah? All right. So if P, okay, so we got a couple new words here, and you can throw things out like this and say, oh, that's the law of detachment. And then no one will know what you're talking about. And then you can sound smart in front of them. The law of detachment says this, okay? So let's read it. If P and Q are, if P and, this is what, how do we write this? If P, then Q is a true statement for P, then Q is automatically true. Okay, what am I saying? If I make it an if-then, like if raining, carry umbrella, then I say, well, today it's raining. What's that mean? That's all the law of detachment says. If the if is triggered, the then is triggered. Make sense? All right. So, look here. If the car runs out of gas, then it will not start. Then you say, well, Sarah's car ran out of gas. What's that mean? That's all the law of detachment saying. If the if is triggered, then the then is triggered. Easy enough? All right. That's the first one, law of detachment. All right. So now we're going to look at some examples and decide if they're inductive or deductive reasoning. All right, every time Lauren has a healthy meal, before she runs, she's able to run further than her sister, who does not like healthy meals. Lauren has eaten a healthy meal, so she concludes that she will run farther than her sister. Inductive or deductive? Definitely inductive. There's no fact behind that. There's a lots of reasons she could be. Yes? Make sense? So inductive. Maybe Lauren's little sister is 2 years old, and that's the reason she can run farther. Probably not because of the healthy meal. Got it? All right, next one. If John is late making his car insurance payments, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed $50. What's the giveaway there? Do you see it? If John is late with his car insurance payment, he will, that's the then, yes? He will be assessed a late fee. You see it? So what are we establishing? What is that? That's a rule, yes? A fact. If he's late, he's going to be given a fee. That's what it's saying. You follow me? So the if got triggered, then the then got triggered. So what are we using here? What is this called? Deductive. All right, ready? Next one. All right, determine if each statement is correct using the law of detachment. One more time, what does the law of detachment say? If the if is triggered, the then is triggered. You don't know if the then is triggered, that means the if was triggered, or it must have happened already. Yeah? So be careful with that. All right, if two angles form a linear pair, their non-common sides are opposite rays. So what are we saying? If they're a linear pair, then they're opposite rays. That's what we know now, right? What's the trigger? Okay, so I'm looking for the trigger of they're a linear pair. Because if I trigger it, they're a linear pair, then I trigger whatever happens afterwards, yes? So read the statement. Conclusion, ED and EB are opposite rays. Okay, so what do we say? AED and AEB form a linear pair. Did that trigger the if? Yes, because it says if they're a linear pair. Fine, they're a linear pair. Then what's true? The angles form opposite. What's true then? Their non-common sides form opposite rays. Is that what we're saying? Yes, there we go. Is that a valid? Yes. Next one's pretty obvious, right? If Micah goes to the beach, she will wear sunscreen. What's the trigger? Goes to the beach, she'll put on sunscreen. Yes? So she's at the beach. So that must be she's wearing sunscreen. Yes or no? No. Yeah? Yes or no? What do you think? Why not? What's the trigger? If she's wearing sunscreen, all we know that if she goes to the beach, right? Beach, sunscreen. There's lots of other reasons she could be wearing sunscreen. Yeah? Maybe she just likes that greasy feel. I hate that feel. That's for the reason I don't like wearing sunscreen, especially on my legs, and they feel greasy for like 3 days afterwards. All right. Is this a valid conclusion? No. The reason the first one is yes is because it's law of detachment. Yes? All right. Next one. All right. So let's read this one. Law of syllogism. That's a fun word to say. You can go out in life. Oh, that's the law of syllogism. And then people will look at you like that face right there. Exactly. And you can throw words like that. I believe that's law of detachment followed by the law of syllogism. You're, oh, yeah. Yeah, and they'll disagree with you and you sound smart. What's it saying? So let's read it. Let's read it. If what? If P, then Q, and if Q, then R. Then? What are we saying? You already knew this. You've been using it you use it in algebra all the time. Kind of. There's nothing wrong with that statement, but that's not really what this is saying. You've been using it. I'll give you an example. If A equals B and B equals C, what else is true? Yeah? Why? Substitution, right? This is called, we also call the law of syllogism, we also call it the chain rule. And the chain rule is if this triggers that and that triggers something else, then this will trigger that. Does that make sense? If P triggers Q and Q triggers R, then P is triggering R. That make sense? All right. That's all it's saying. So it's kind of like if you give a moose a muffin, right? Have you ever read that book? If you give a moose a muffin and he goes to this, he'll do this. And if you do this, that'll happen. And if you do that, I've done it with you before, right? You don't do your homework. I've done this before in the class. You don't do your homework, what happens? You get low grades. Yes? If you get low grades, right, you're going to feel bad about yourself and you're going to want to feel better, so you're going to fail. Then you're going to go to summer school. When you go to summer school, you meet other people who were doing bad. And so you start becoming friends with them. And then you're both bad kids doing friends to each other, so you guys start making a gang, right? And if you make a gang, you're going to definitely be selling drugs and probably taking drugs and probably become addicted to drugs, right? And probably end up in prison at some point. What am I saying? If you don't do your homework, you're going to end up in prison. If every one of those statements along the way, if this makes this happen and this makes this happen, you can take it all the way down and make absurdity. Yeah? Make sense? All right. That's all this is saying. That's a chain rule. And you can see why I call it the chain rule, right? A cascade of events. So don't do your homework. If you don't do your homework, what's going to happen? I'm just telling you. You've been warned. All right. So look. If you get a job, then you will earn money. Getting a job triggers money, right? If you earn money, you will buy a car. Is this a lost syllogism? Yes, because this triggers that, and then that triggers the next thing. So the valid conclusion is if you get a job, you'll buy a car. Make sense? All right. Use the lost syllogism to make valid conclusions about each statement. All right. If a figure is a square, then it has 4 right angles. What's the trigger? If it's a square, then it has 4 right angles. If it has 4 right angles, it's a rectangle. So look what it's saying. Look what we're doing. This is triggering this, and then that is triggering that. So in a sense, you can take this sentence and like write it right here. Does that make? You don't have to write it that way, but you could write it right here, right? If figure is a square, then it's a right angle. If it's a right angle, then it's a rectangle. You get it? So what's a valid conclusion I can make? If a figure is a square, what we just said is right, but we just had to formalize it. Yeah, we have to write it. Then what? All right, so this next one, this is the one I was talking about at the beginning of the period, was my first year doing this, I could not figure out how this was the law of syllogism. And then near the end of the period, one of my polite students came up to me quietly and said, Mr. Gillespie, it's real easy, blah, blah, blah. And then I was like, oh my gosh. It was dumb that I didn't see it. All right, so let's look at it. If you're tired, then you will not do well on a test. If you don't get enough sleep, you will not be tired. And I was like, well, how do I write the law? How do I make a law of detachment law of syllogism for that? Hold on. You guys see it? Look, I'm saying, look, if you're tired, that's A, then, so not do well on a test, we'll call that B. A is tired, B is not do well on tests. You get it? If A, then B. What is this saying? Is that A or B? Oh, that C makes A. And when I wrote it like that, when the kid wrote it like that, I was like, oh. You guys see it now? What do I do? If you're tired, then you will be tired. No. What are you doing? You're right. Look, if I make up a statement and I say one statement, then I say another statement, does it matter which order I put those statements in? These are two things that are true. The first statement is true, and the second statement is true. Can I rewrite this? C goes to A, and A goes to B. And I didn't see that the first year, and it was kind of embarrassing when he explained it to me. Yeah? You get what I'm saying? So it doesn't matter. If I had written this first, if I had put this on top, you would never have missed it. So just be careful with that. All right? Now, if it had been written opposite, right? If it also said, when you're tired, you will not get enough sleep, there's no way to link them. Okay? So, what's the valid conclusion? If you don't get enough sleep, come on, we're not going to write. Enough sleep. You won't do well on the test. That's it. Easy? That's it. So, a couple things. One, inductive and deductive reasoning. Inductive is based on patterns. Deductive is usually easy to catch because it'll have an if-then in it. Yes, it'll have a rule that it follows, yeah? And then we got law of detachment, which means if the first thing happens, the second thing happens. And then we got law of syllogism, which is like the chain rule. If this happens, then that happens. If that happens, then the next thing happens. Yeah, go ahead.
Are you trying to find the AC, or are you trying to find...
You're trying to write a valid conclusion based on the information there. Yeah. You couldn't go from A to C. Because C goes to A, or you couldn't go from A to C, I guess. You can go from C to A, because C goes to A, and then A goes to B. Well, you can go from C to B, but you can't go from A to C. There's no way to get from A to C. You can go from C to A, but not the other way around. Yeah? Any other questions? All right. That's your homework tonight.